Let's look at some examples from Chapter 2. A very important example might be finding the LCM, sometimes called the least common denominator. The steps are to prime factor each number. So let's do that for 54. 54 is 9 times 6, but 9 breaks down to 3 and 3. 6 breaks down to 2 and 3. Writing this more concisely, we could say that we have 2 times 3 cubed. Do the same thing for 36. 36 is 4 times 9. 4 is 2 times 2. 9 is 3 times 3. Written concisely, 36 is equivalent to 2 squared times 3 squared. So we have now prime factored each number. Now we want to list as a product the different factors. The different factors between these two numbers are 2 and 3. The last step is to find the exponent on each factor. That is, the exponent is the highest exponent from either factorization. So therefore, the digit 2 raised once here, but raised twice there. The highest power we see is 2. The digit 3 is raised to the third power here, the second power there. The highest power between either factorization is 3. So the LCM is 2 squared times 3 cubed. But let's come up with a final number for that. 2 squared is 4. 3 cubed is 27. And 4 times 27 is 108. 108 is the least common multiple, meaning that 54 and 36 go into 108, and there is no smaller number than that for which it works. Let's try to find another example. How about subtracting mixed numbers? And there are a couple ways to do this problem, but I prefer my way of doing it. It's a little easier in that it works with smaller digits if you do it my way. So I line up the mixed numbers in a vertical format, 9 and 1/6, underneath it 5 and 7/8, and we are subtracting. We want to subtract the fractions, so we want to subtract 7/8 from 1/6, but we need to find the LCD and then convert to equivalent fractions. 1/6 is the same as 4/24. 7/8 is the same. 7/8 is the same as 21/24. We would like to subtract the fractions, but 21 is bigger than 4, so we're going to have to borrow. Borrow 1 from the 9, so the 9 becomes an 8. The 1 that we borrowed, we're going to rewrite as 24 over 24, meaning 1. Add these two fractions, that gives me 28 over 24, an improper fraction. And now we're able to subtract the fractions by subtracting the numerators, keeping the denominators. That gives me 7/24. Finally, we subtract the whole numbers, 5 from 8, which is 3. So we have a mixed number answer, but we always look at the directions of how we write answers. We want either a whole number or a simplified fraction. So now we need to convert the mixed number into an improper fraction. We take the denominator 24 times 3, add the 7, put that all over 24, and that gives me a simple fraction of 79 over 24. Simple fraction or an improper fraction in this case. Lastly, let's divide some mixed numbers. The way to divide mixed numbers is to convert the mixed numbers into improper fractions. So 4 and an 1/8 is 8 times 4 is 32, plus 1 is 33 over 8, divided by 1 and 5/6 is 6 times 1, plus 5, that's 11 over 6. We now need to convert the division, and the way we do that is we change division to multiplication if we reciprocate the fraction that follows the division symbol, so that becomes 6 over 11. It is now much easier if we reduced first then we multiply rather than the other way around. So I noticed 11 goes into itself once, 11 goes into 33 3 times. 2 goes into, excuse me, 2 goes into 6 3 times, 2 goes into 8 4. Now we're able to multiply. 3 times 3 is 9, 4 times 1 is 4. We're asked to leave it as a reduced fraction, so that is a proper answer.